Hello everyone and welcome to another video. So in this video I'm going to talk about the MNIST dataset. Okay, so very quickly I'm gonna have to import Keras. Okay, I am on a Python file. We're gonna import Keras, and Keras has a lot of datasets out of the box. Okay, so let's import the from Keras.datasets. I'm gonna import the MNIST, which is a data set of handwritten digits, okay, or digits. So we're gonna import this data set. I'm gonna show you guys how it is. So this data set returns two tuples, okay. The first tuple I'm gonna create, we return the x and y. So we could create two variables, x and y, a tuple. And the second one returns the test or validation. I'm gonna keep them empty. Okay, so and to load the data set, we're gonna call mnist.load data. Okay, so that's how you can load this data set. I'm not going to show much about this, but because I already have this data set downloaded, I just can call print x, and I'm gonna execute, and I should be able to see the features there are in this data set. So showing me using TensorFlow as a backend as usual. Also, it is necessary to do some normalization stuff, because in this video I'm going to show you guys how to train a multi-layer perceptron to solve this problem, okay, which could be solved in a lot of ways. So let me see. It's taking quite a while, as usual. Okay, so let's wait. So I'm gonna show you guys where this data set is located. Oh yeah, so it has loaded. As you guys can see, it showed me a bunch of zeros. Okay, this is a three-dimensional array. Okay, so that's it for the data set. Let's iterate over this. I'm gonna call sample, just to show you guys how this works. So you guys can see exactly what there is in this file. So let's see. Okay, as you guys can see, there is bunch of data. This data is pixels. Okay, so the range starts from 0 to 255, which are the range of pixels. So they are numbers. Okay, so they are 28 by 28 matrices. Okay, so yeah, this is going to take a while because we're gonna print let's just print the first 10 digits. Okay, just the first 10, because print 60,000 is way too much. So I'm gonna print the first 10 digits. Okay, so let's just do that. And then let me say, I think I need to increase this a little bit to the next 28. Okay, so as you guys can see, okay, there is this. Oh, this is I think is a row, because I'm just printing the first image, actually the first 10 images. Okay, so we have, this is I think it's a 0. It's very hard to recognize the digits by just seeing the arrays. Okay, so that's it for the data. Let's keep to the model. So let's because we're gonna use the a multi-layer perceptron, we're gonna use dense layers. But first of all, let's just import the model. Okay, I'm gonna import a sequential model, and let's import the layers. I'm gonna import just the dense layer. Okay, so let's create a model. Model will be equal sequential, and we need to add a dense layer. So this will be a multi-layer perceptron. In this dense, I'm gonna put 64 neurons. Okay. Input dimensions or input shape. Yeah. Okay, so we're not going to use the input dim. We're gonna use the input shape because we can work with 3 batches. Okay, we're gonna learn about more about this later on. So right here, what I need to do is to convert the 2-dimensional array to a 1-dimensional array. So to do that, we're gonna actually reshape the x. So we're gonna call the function reshape because they are numpy arrays. We can call the reshape function. We're gonna reshape then the 60,000 samples into a 784 array. Okay, so they are 28 by 28 matrices or vectors, and we're gonna convert them to a 784. Okay, so they are a matrix. We're gonna convert it to a vector because we're gonna work with the dense layers. But if you are working with convolutional neural networks, we could try to use other input shape. Okay, so let's call just as type float 32. Okay, that's good. And the y are the numbers. Okay, so to convert the y to labels, we're gonna use a function that is available on Keras. Okay, which is called categorical. Okay. Let's pass the y at non-classes. So the number classes are 10 because we're gonna classify 10 digits. Okay. So after that, we can now define the input shape. The input shape is the number, this number. Okay. 784. And we're not going to pass any batches, so that's just it. And let's add another dense layer, which would be the output layer. The output layer will have 10. I was forgetting the activation function right here. So the activation function, let's just put a relu, very default. So let me see. I'm gonna try to drag the codes up a little bit. So the activation function on the output layer needs to be a softmax. The reason why is because the softmax will output the probability. Okay, it's very simple. And the probability. Okay, and the probability. So the softmax function outputs the probability distribution of the samples. Okay, so you need to use this. After we can call ModelCompile Optimizer. Let's use a Atom Optimizer. Okay, and in the loss, because we are working with the softmax. Softmax needs to be the categorical cross entropy, okay, which is the function that works together with the softmax function. Let's call the metrics. I'm gonna put a precision or accuracy metric, categorical cross entropy. Let me see. Okay, so I could now call model.fit xy. And let's put epochs. I'm gonna put 100 to be very. I want this to be very fast. So as you guys can see, it's not a lot of code to write to get started with deep learning. If you guys have any doubt on how this works, you guys can actually comment down below. Yeah, I was forget something. Yeah, I forgot to. Let me see. I forgot a quote. So it's going to execute. I'm gonna show you guys how the thing works. So Keras has a simple visualization to the progress, to see the progress. Okay, it is very simple. You can see the epochs, the steps that are being executed, and the loss and the accuracy, so on. So this will take a while. So it's running. Each epoch will take about 10 seconds. Okay, and the loss is this number. The loss means the error, and the accuracy, as you guys can see, is very high because we are testing the. We are not using a validation data set. We are using the same data set. So when it hits 90%, I think it's very good. So the main thing here is to achieve something close to 90% of precision, okay, or accuracy. So when it hits 100, actually 90%, I think the model is pretty much done. Okay, we cannot after the 19% to get more accuracy becomes more difficult. So each step takes 109 nanoseconds, as you guys can see. So it's very, very fast. We are inputting 60,000 images. Okay, they are small, but they are that is a lot of data. Okay, so we are pretty much stuck in the 73%. So I think we have reached our stuck. We are stuck right here. So what can we do to overcome that? We can add more layers here, and we can create a deeper model. Okay, so I'm gonna add more layers here. Activation equal relo, and I'm gonna call the model print model.summary, so you can see how many parameters we have and that stuff. So I want to see how many parameters I have in this model. I'm going to see how much time I've been recording. So it has been 30 minutes. Let's go on. So I'm going to see if I can get a better model by training this model, okay, with more parameters. So the model should now have more than, I think, something close to 1 million parameters. Yeah, it's actually 118,000 parameters. I could increase that. So their accuracy, let's see. So each epoch would take about 14 seconds actually. So let's see if we can achieve a better precision or accuracy. So I think we are stuck in 60, if I'm not mistaken. Let's see if we can have a better precision. So the thing is, guys, if you wanna achieve a better model, we should definitely study the specifics of the problem, okay? Because we are working with images, okay? We are working with a two-dimensional vector. The better solution would be convolution neural networks in this case, which have outperformed multi-layer perceptrons. Okay, it is taking a while actually. So what can we do? Let's add more layers. Let's add 500 right here. I'm gonna use the two exponential numbers, as you guys can see. I usually do that, so I don't usually put 100 here. I would put 128. So let's add more parameters. I think if you have more parameters, we are able to get a better model. We have 400,000 parameters now. So each epoch would take about 40 seconds, which is not that much, but if you are running this on a GPU, you should be able to run each epoch 10 times faster very easily. So each epoch would take about 4 seconds or so. So the accuracy here is not very good. So let's see what we can do. So guys, this video is about teaching you guys how to solve the problem, okay, with this model. So the model is stuck with a poor precision. So let's change things, I think. Also, let's change the things a little bit. So let's create two. Let's get the X and Y. I'm gonna talk about what we're gonna do here. So what we're gonna do is pretty much get the validation data set. Let's get the validation data set. So the validation data set has 10,000 images. I'm gonna convert this to float 32, and I'm basically I'm gonna convert this to categorical. Let's convert this to categorical. Okay, let's use dot to categorical, and let's pass a parameter to the fit method, which is called validation data. Validation data. When we pass a tuple, okay, let's pass a tuple xy. And we could pass another parameter which is called batch size, which I think that should be the problem, okay, because the algorithm was probably looking to all samples, so I should be passing the batch size argument. So I think now we are able to produce better results. So let's see. I'm hoping for that. So our model has the same parameters. We are stuck, and we're still stuck in the 18% accuracy, which is not good. So let's see what we have here. Okay. As you guys can see, the val accuracy shows us the accuracy on the validation data set. We are achieving 21% and now 27%. It's actually quite weird because we are getting higher values than on the training set itself. As you guys can see right here, we have 25%, and here we have 27. Here it gave us 31%, and here 33%. So that's something to look for. So yeah, let's see if we can achieve um, some better model by training this. Yeah, it's progressing, but I don't know. The loss is not becoming smaller um, very quickly. Let's see. Okay, so if you guys have any doubt on how to get this working, if you guys want to see more about the specifics, okay. So the accuracy is closer to 40%, which means that if I train this model for 3,000 epochs, I should be able to get a higher accuracy, something close to 90%. But the problem is the model is not progressing as quick as I'm expecting. Okay, so still stuck in the 35%. So let's add more layers. I'm gonna add 700. Let's do that. Our model will have much more parameters. I think 1 million or so, which is it's too much parameters. But let's see if we are able to get this working. If we can train this model. So let's see how many parameters we're gonna have right now. The video is on its 21 minute, which means that this video will be very long. So, but I think it's important to show you guys how the training can be very um, uh, might bother some people because you have to try different things and try to figure out what's wrong and what's not, why it's not working. Okay. So the accuracy is very low, as you guys can see. Yeah, the accuracy is very low. I'm still trying to figure out what's wrong with this model. Um, let me recapitulate what's going on here. So we are inputting 784 to this model. So this bunch of inputs is going to be thrown up, computed with this bunch of neurons, which will be computed with this much of neurons to this much of output classes. So if we multiply, let's just do the math here. Let me just open up the calculator. Let's do the math. So this is the new calculator from the Windows Microsoft, because I have updated my Windows. So okay, so we have 786.8. Okay. Let me see with details. Okay, so let's multiply that by 512. Oh, yeah, I did twice, so I need to do it again. We have this bunch of... it actually doesn't show me, so we have it. Okay, so that times that. The number of parameters, it's quite weird. I think Let me see what's going on here. Yeah, I cannot. Okay. So we have 400. Okay, so the multiplication. Let me see. Okay, so the thing is. Okay, so I see what's going on here. So if you guys. Okay, so I need to. I wanted to move this up, but it's not working. So I need to do that. So to pause the training. So you guys can see right here we have 768 values, and right here we have 7,000 690, which means that we have 10 more. So we have this times 10 plus 10, which are the biases. Okay, so just to let that be clear, just to clarify. Okay, so clarify. Okay, yeah, that's good. So the model is taking a lot of time to train, as you guys can see. Let's chat and chill. So if it takes about 30 seconds to run each epoch, it should take about 3,000 seconds, which will be equal to, if I'm not mistaken, 3,000 seconds. 5 minutes. No, 5 minutes. No, 50 minutes. 30 times 100. Two epochs 1 minute. Yeah, 50 minutes. So it should take about 50 minutes to train with this model with this much parameters, which I don't know if it's a quite. It's not very. It's not that fast. Okay, take it. If you spend 1 hour training a model, it should be something worthwhile. So the accuracy is pretty much stuck. As you guys can see, we didn't have any progress. So I think I need to stop the training, and I need to try to figure out what's going on here. So I need to try. Yeah, I just realized what I was doing wrong, guys. Yeah, sorry for that. Sorry for making wait this much. What I did wrong was I forgot to normalize the data. So that happens, and you guys should be aware of that. Okay, so x will be equal. Yeah, I forgot to normalize the data, which is because it's why our model is not training. So let's do that. Let's remove the number of parameters. Let's just train a simpler model, and we should be able to see the output easily. So sorry guys. So yeah, I'm gonna comment right here. My bad. I forgot to normalize normalize that data. So yeah, that's the pretty much the problem that we had here there. So you guys can see right now we have reached almost 100% of accuracy. Okay, so yeah, we have pretty much reached the goal of at the beginning, which was to get a model which would perform 19% with 19% of accuracy. So let's talk about what I did wrong here. I forgot to normalize, as you guys can see, right? So to normalize, we just pass the array or matrix, in this case an array of 3 dimensions, and you divide by the maximum number. In this case, the maximum number of a pixel is 255. And by doing that, you're going to normalize all the pixels, and we're going to have numbers in the scale from 0 to 1, which is the scale which we usually work in deep learning. Okay, so I'm sorry for the confusion. Okay, but hopefully we have learned something new on this video, because you need to remember to normalize the data. If not, we should be disappointed because the model is not going to learn the data. Okay, so thanks for watching this video. See you guys next time.